Alright, so in this video, let's deal with Sig Figs. So Sig Figs are essentially used to express a number with a level of accuracy that we have. In science, we measure stuff, we get quantities. When we want to express it with the degree of accuracy, we don't want to lie and give more accuracy, or we don't want to give less accuracy than is needed. So that's why we have sig figs. We can use to express our number properly. So there's many different rules that we have for significant figures and determining the number of significant figures in a number. And we'll be going through those rules. Hopefully this video is going to help you sort of determine kind of a mindset of thinking about how to determine if this is a sig fig or not, like a certain digit, and how you can go through a bunch of steps in your mind to determine that quickly. So let's look at it. So let's say that we had the number 1, 2, 3, 4. I like to start with this number. It's very nice. These are actually all significant in this number. There's no thinking required, very little thinking at least, because this is our first rule for significant figures. This is going to be 4 sig figs. 4 sig figs. Let me do this in a different color. Do this in red. This is 4 sig figs, okay? 4 sig figs. Now, let's say that we had another number, so 2, 3, 4, 1, 2, 0.123. This is going to have, of course, all of these are significant. So this is going to have a total of 8 sig figs. Okay? Now, I don't want you to have the conception that all numbers are significant, because that's just not true. If that was true, that would be too easy, and we wouldn't really need to study this, and I wouldn't need to make a video. So this is going to be true. So this is our first rule. So all non-zero numbers or digits, numbers are always significant, and this is always going to be true. Always. Look for these always and never. Never. So significant. Okay. So this is going to be always true. So let's do one more just for fun. So 3, 4, 1, 2, 9. And I did this in the wrong color, but it's fine. So and then 1.123, 4. I don't know. This is just all going to be significant. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So yeah, this is not too bad, right? All of these are significant. So it's 9 sig figs. But this is just for non-zero numbers. What if we have a 0? So let's say we had 101. Would this be significant? Would 102.10, would these zeros be significant? I don't know. Well, we'll look at that. So let's look at the second rule. And this second rule is also pretty easy, but it does incorporate some zeros. So let me delete these examples. So the second rule is for zeros that are in between non-zero numbers. So if we had 101.21, is this zero significant? Well, the rule states that any zeros between non-zero numbers are always going to be significant. So this is significant, this is significant, this is significant, and this is significant. We know that from the first rule, always. This is between, so it's going to also be significant. That's actually our second rule. It's not very hard either. So this is going to be 5 sig figs. Let's go one more, right? So let's just do 102.101. All of these are, of course, going to be significant. Let's see. This is all going to be significant. 1, 2, 3, 4, 5, 6. They're in between, so they're significant. You can think about it like that. Okay, so these are all 6, right? 6 sig figs. Very nice. So let's write down the rule. So zeros between non-zero numbers are always significant. Another always significant. significant. There you go. Let's do one more, and this is going to be interesting. So let's say we had 1002000.100101. How many sig figs? Let me tell you that all of these are significant. So we know this. These are all significant. These are easy. This is between. Now these are also technically between. All you have to do is just look at, like, say this one. You might think that, oh, this is a 0, this is a 0. So is it significant? Question mark. Well, you just have to think about, if you kind of go out, right, in both directions, you'll see that there is a number that's non-zero, so it's technically still in between it, right? So it's still gonna be significant. Okay, just know that. This is also significant, this is also significant, this is also significant. Just basically all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 significant figures in this one. 14 sig figs. Hopefully this makes sense. Okay, let's look at the next rule. This is going to be another quite simple rule here. So the third rule says zeros before numbers, right? So basically, like, if we think about zeros that are in the starting of the number, so basically before all the numbers, so 0 before numbers are never significant. Never. Okay, so never significant. What do I mean? So let's underline. So what do I mean by before numbers? Again, as I said, they're numbers that, like, they're zeros rather, that are before all the numbers that exist in this overall number. So everything that's, I guess, in the starting of the number. So it's like going to be like this, right? So we had this number, say, right? These zeros are always going to be insignificant or not significant. And all of these are going to be significant, of course, because we have our rules that say they are, the other rules. So this one has a total of 6 sig figs. Now let's do like a couple more. So this is not a very hard concept. Hopefully this is just going to be 2.34101. I don't know. I'm just trying to make it as complex as I can, but really this is not hard, right? All of these are significant because the zeros are in between, or it's a non-zero number. And then these are before, so they're not significant. So this is all going to be, this is 10, I think. 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 10. 10 sig figs. Let's do just one more quickly, real quickly. Let's say we had 0101.1. Again, this is just 1 0, but it's still insignificant. 1, 2, 3, 4 sig figs. 4. All right. That's quite simple, okay? Quite simple. Now, what if the zeros are after? And this is our last rule, but it has 2 parts. What if the zeros are after? So let's say we had 101.1. Let's actually not do the decimal. So 101.11.00, right? So let's say we had this. Are these significant zeros? We know these are going to be, all of these are significant. This 0 is significant between. But are these zeros significant? We talked about before, we talked about after. No, we didn't talk about after. We talked about before and between. After, there's 2 sets. So there's actually 1 set, 2 rules, A and B. So if it's a 0, let me just write it out and then we'll explain. So zeros after numbers are not significant. Actually, I'll just say never, right? Absolutes. Let's use absolutes. Never, because I like absolutes when you think about this, right? When are never significant when no decimal point. No decimal point. Hopefully this is making sense. Let me try to make sense of it a little bit more. So, whoops. So if we had like a number like 101.1 1, 0, 0, right? Say, for example, actually no point, sorry. 1, 0, 1, 0, 1, 1, 1, 0, 0. Or even this one, really. This is this one, so I just rewrote it. But this is, for this one right here, all right, we would see that we have this, and this, and then 0 in between. But these zeros are after, and there's no decimal point here, so this is not significant. This is just going to be 5. 5 sig figs. All right, and so that's that. And so let's see. Let's say we had 1, 0, 2, 4, 9, 0, 0, 0, 0. Doesn't matter how many zeros I add. They'll never be significant if there's no decimal point right afterwards, right? So let's see. We have 1, 2, 3, 4, 5. Okay, it's very simple. 5 sig figs. I just added a bunch of zeros, but we still have only 5 sig figs. Doesn't make a difference. Let's do just one more real quickly. So 1, 0, 2, 4. I don't know why I keep choosing the same numbers. Let's do like 3, 2, 1, 0. All of these are significant, and then this one is not, okay? And this is going to be 1, 2, 3, 4, 5, 6, 7, 7. And that's not a decimal point. It's just 2, 3, 4, 5, 6, 7 sig figs. Not too difficult, hopefully. Very simple. Now let's do the last part. What if we do have a decimal point? I've been talking about decimal points too much, and it's kind of interesting. What if we do have one? Well, if we do have one, so zeros after, so we're still dealing with after, that's why it's A and B, after numbers are always significant when there is a decimal point. This might seem weird, but let's see. When decimal point. Okay. What does this mean? Well, if we have like 1, 0, 1, 0, 0, 0 point 0, 0, 0, this is interesting. Okay, this is interesting. Let's see. So these are significant, right? Because they're after the decimal point. But these are significant as well. But would these be significant? Because we have zeros that are technically, well, we have a decimal point. Well, technically they are significant because this is after, right? These are, so this is our number that's our non-zero number. And then there's zeros to this direction, right? In this direction. These rules are talking about zeros that are after numbers that are from 0 to 9. So, from 1 to 9. So this is our line, and then we can draw it from this side. All of these are zeros, and we do have a decimal point, and they're after. So these are also significant according to this rule right here. So they're always significant. All of these are. So even these, of course. So all of these are significant, which is going to be, I think, 9, right? 9 sig figs. This is an interesting one. Just think about this, because we have zeros are after, and all of them are significant because we have this decimal point, according to this rule. And it works. It's a rule. So this is going to be the next one. Let's see. Let's do one that's like 12301.00. All of these are significant. All of these are significant. 1, 2, 3, 4, 5, 6, 7. 7 sig figs. All right. Whoops. Sig figs. Let's just do one more just for the sake of it. Let's do one more. Okay, so let's say that we had 0, 0, 1, 0, 2, 0, 2, 0. Okay, this one right here. This is going to be fun because this is not just like all of them are significant, which I've been doing a lot, but this is just going to be zeros before are never significant. This is kind of using a bunch of rules actually, so these are never significant. And then zeros, these numbers are always significant. This is in between, so it is significant. Zeros after, which is this, is significant if we have a decimal point, but we don't, so this is also not significant right here. So guess how many we have? 3. 3 sig figs. And we're done. Okay, so hopefully this video has made sense. These are the 4 rules that you need to know. 4 rules right here. So I've tried to fit them. These are the 4 rules that you need to understand, that you need to have commit to memory if you're taking a chemistry test or a biology test or a physics test, right? Chemistry or physics. These are the 4 rules, and this one has 2 parts. Remember these, you should be good with Sig Figs. Stay tuned for my next video and where I'll go over examples that are a little bit more complicated because they involve all of these rules, okay? So they're examples that have all 4 of these rules just kind of combined. So you need to think about all of these rules, and that's going to help you the most because when you have like examples that are focused on these rules, and then you're not going to really know how to apply them when they're in the wild. So we'll be doing examples in the next video where it's in the wild, and you can pause the video and try it on your own before you look at the answer.